Hi everybody, welcome to the first lesson here of distance learning. I'm going to be talking to you about the simplest circuit that I can think of at least. I'm going to be teaching you from my kitchen here today because it's got some of the materials I need. Alright, so in terms of the simplest circuit, a good example I think would be right here. Okay, so keep some flashlights underneath my kitchen sink just in case the power goes out and all of that. And I got one here that I'm going to use to show you just like the minimum of what you need to make an electric circuit. All right, so this was working, the light's turning on, so hopefully I can get my demonstration to work as well. Okay, what do you need for a circuit? Well, you need something to power it. Okay, you need some kind of source of energy, and in a flashlight, most of the time, we're talking about batteries here. So this flashlight requires two batteries. So the batteries provide the energy, and then a circuit's going to need something to use up that energy as well. Okay, we don't just want the batteries pumping out energy for nothing. And in the case of a flashlight, the energy is going to be used up with the light bulb. Okay, it's got the flashlight bulb here. And the question is, how do I get the energy from these batteries into this light bulb? Okay, well, that's what the case of the flashlight is designed to do, at least the inside of it. The outside of it is made up of an insulator, so you can hold on to it. You won't mess up the circuit by holding on to the outside. What's going on the inside, that's a bit harder to see. So I'm going to do a much simpler version. You need to connect this power source to the thing that's going to use the power using some kind of material that lets electricity flow through. And hopefully you remember what the name is of the material of any material that lets electricity flow through. I'm talking about conductors here. Okay, it needs some kind of conductor, and the most effective kind of conductor would be a metal. Electricity can flow really easily through a metal, which is also why I'm in the kitchen, because I've got something pretty handy to use as a conductor. I got my aluminum foil. All right, aluminum is a metal. Electricity can go through it, so I can take a strip of it. And aluminum foil is really flexible and all of that, so I can manipulate it really easily. So what I've actually already done, just to save some time, is taken a strip of aluminum foil. I kind of folded it up a bunch of times to try to make a wire, and I'm going to try to use this to transfer the energy from a battery into this light bulb. Okay, so let's see if I can get that going. All right, so I'm only actually going to use one battery because, well, in a flashlight they stack the two together, but I only have two hands, and it's going to be hard for me to hold them both together and get it all connected. So I'm just going to try to use one battery. Hopefully that's enough energy to light this light bulb up. All right, so a battery has two ends to it. This is the positive end. This is the negative end. All right, it says so right on the side of the battery here. There's a positive sign and there's a negative sign. So I'm going to take my wire, my makeshift wire, and I'm going to put the negative end of the battery to one end of my wire. I'm going to take my light bulb. The light bulb's got a little contact point at the bottom there. I'm going to hold that contact point to the top, the positive end of the battery. And then I'm going to take my wire and I'm going to connect it. Okay, so the light bulb's got some metal around the side. Metal's conductor. So if I touch this conductor at the side of the light bulb, hopefully I get some light. and you see I get a little bit of light. All right, that's good. This is probably half as bright as the flashlight normally is because I'm only using one of the two batteries. But there you go. I got my circuit to work. Okay, and that's the simplest circuit I can think of. It has three things in it. Power source, something to use the power, and something to connect the two of them. I have that written down on the PowerPoint slides here. And this is available on Google Classroom. So there you go. Those are the three things. Power source, something to provide energy. Load, something that uses the energy. So the light bulb was the load in the example I was showing you with the flashlight. There's all kinds of different loads possible. So it could be a light bulb. It could be a speaker, because that uses electricity. It could be heat for an electric heater. It could be a motor, like if you're running a fan or a blow dryer or something like that. And then conductors, a material that allows electricity to flow. You got to be able to connect the power source and the load. So the next thing I'm going to show you is a simulation on the internet. Okay, so this is produced by the University of Colorado. They're called PhET simulations, and I actually posted a link to them on Google Classroom. Under classwork, if you go all the way to the bottom, there's a general info, and I'm going to click link to PhET simulations, open that up. All right, now I'm going to click play with a sim. And then I'm going to go to the top here, simulations. I'm going to pick physics because electricity is part of physics. And then off to the side, there's all these different kinds of topics in physics. You go to the very last one where it says electricity, magnets, and circuits. And then the one I'm going to pick is called the Circuit Construction Kit. Now let me see if I can make this a bit bigger. Okay, Circuit Construction Kit. When I pick a simulation to use, I'm going to always try to pick ones that have this symbol on it. This is a 5 symbol, standing for HTML5, because those ones should work on your Chromebooks. Okay, so I open the Circuit Construction Kit, click play, and here I go. All right, so on the left side here, I have all these materials I can use. So I'm just going to take out a battery, click and drag it. Now if I click on these red circles, I can kind of rotate it and reposition it. All right, now I'm going to grab a light bulb, click and drag. And now I got to get these connected. So I'm going to grab some wires. So here's one wire. So what I want to do is I want to attach one end of the wire to one end of the battery. Grab the other end of the wire and drag it to one end of the light bulb. And you'll see the light bulb is not turning on. That's because I actually need to connect the other end of the battery to the other end of the light bulb as well. That makes a full circuit. So I need another wire, connect it to the other end of the battery here. And I'm going to take this, I need to connect this to the other circle on the light bulb here. I'm actually going to just grab a third wire to do that, just so I don't get things all cluttered. And so connect that and connect that. And there you go. The light bulb is turned on. And you may also see that there are blue dots inside. Let me see if I can zoom in. So actually maybe I cannot zoom in. That might be the biggest we can get. But you may see these little blue dots moving around. These blue dots have a minus sign in them. they're actually standing for electrons. So what happens inside the circuit that you can't really see with my flashlight example, but you can see with the simulation, is that when the circuit's all set up, electrons are actually moving round and around and around. So what actually happens is the power source pushes these electrons. They're applying a force and pushing these electrons. And they move around, and when they get to the light bulb actually it's slowing them down. Okay, we say it's offering resistance and slowing down those blue dots. And as it slows it down, it actually takes its energy and turns it into some other kind. And in this case, that would be light energy. I'm going to show you what happens if you don't have a light bulb. So get rid of the light bulb. Now nothing's happening right now because, as you see, I've disconnected the circuit. Okay, the electrons, there's this gap of air and it just cannot move through air. But what if I connect them? Boom! Now you can see just how fast these electrons are moving around when there's no light bulb. They're moving so fast that it caused the battery to kind of blow up. So this energy that the battery is providing, we call that kinetic energy. Kinetic energy is the energy associated with moving things. So the battery is providing these electrons with a lot of kinetic energy, which if there's no load for that kinetic energy to go, it's going to cause a fire. So we always want to make sure there's a load. Put the light bulb back in. Always want to make sure there's a load for that kinetic energy to be changed into some kind of other energy that'll slow everything down. So you see the blue dots are moving a lot more slowly. All right, so that's what happens inside the circuit. I just added a couple more slides to this PowerPoint, which is available on Google Classroom. This is just a diagram of the simulation I just showed, labeling the basic parts of the simplest circuit, and then a description of what I was talking about, right? So if you can't remember everything I said, it's written down here for you to read. So you can do what you need to with these notes. You can print them off if you have a printer. You can save them all onto a folder on your Chromebook, whatever you need to do to have a copy of the notes. And after this video, I'd like you to complete the Google form that's posted on Google Classroom right after this video. That just has a few questions based on what I said, for you to check in with me to see how you're understanding this content. All right, thanks for watching, and we'll see you in the next video.